Dear students, good morning. In this video, I will be telling you first the I will be telling basic laws of kinetic theory of gases and some fundamental laws of gas. First, I will write Boyle's law. Boyle's law, mathematically PV equal to K, or you can write P1 V1 equal to P2 V2. Charles law. V equal to Kt, or V1 upon T1 equal to V2 upon T2. Pressure law. Pressure law. P1 upon T1, T2 upon T2. But remember here, in this case, mass and temperature constant. Here, pressure and mass constant. Here, volume and mass constant. Pm, Vt, Vm are constant. Then general equation we can write P1 V1 upon T1 equal to P2 V2 upon T2, which further can also be written as it can also be written as PV equal to RT for 1 mole. R temperature everywhere taken in Kelvin, or for n mole PV equal to nRT. Here n the number of moles, or we can write here M upon capital M RT. Capital M is the gram molecular mass and small m is the mass of gas under consideration. This equation can also be written as PV equal to X kBT, where kB equal to R upon N. Here N is Avogadro number and X here is the number of molecules in the given mass of gas. X, actually in books it also written here N. I have taken X. What is X? Total number of molecules. Total number of molecules in given mass, given volume of gas. We have to keep in mind all these things. Then X, Kb, Boltzmann constant, Kb. Kb here is equal to Boltzmann constant. And equal to 1.38 10 to the power minus 23 joule per mole. I hope you remember the concept of mole. Now, using all these, we derive here concept of pressure exerted by gas. P equal to 1 upon 3 rho C square bar. C bar is called root mean square speed. Or this can also be written as here C square bar equal to 3P upon rho, and here C bar is also under root 3 RT by M. This is kinetic theory of gases. M gram molecular mass, R gas constant, T absolute temperature. And then using this concept, we we derived the concept of temperature. Concept of temperature. सॉरी बच्चों, वो गीला था डस्टर. From this, actually, we derive from this all relation kinetic energy, which is equal to internal energy. Internal energy of ideal gas. Kinetic energy per mole, which is equal to also internal, because internal energy is the sum of kinetic energy of molecules, and it entirely we have proved equal to 3/2 RT. Using this concept, we have derived it. Using this concept, we determine the specific heat CV and CV. CV 3/2 R and CP 5/2 R. This is from kinetic theory of gases. Kinetic theory of gases. Dear student, actually you might be thinking this job is very simple for me. No, I am studying for last 5 years the whole physics, which I have taught throughout my life again and again, and I am finding so many things are not interpreted correctly by different authors. But in competitive exam, the question comes taking all consideration. So these value of CP, CV was true, I have told you, for monoatomic gases. For diatomic gases, these value of CP, CV, which we have derived theoretically, do not match with the experimental value. And the error in concept gases lies in the assumption that molecule of every gas behave like a hard sphere. And while dealing with kinetic theory of gases, we have taken only molecule of every gas as a sphere, and no further structure was taken up in consideration. Then I told you that different gases have different number of atoms in their molecule. Monoatomic gases like helium, argon, krypton, radon are monoatomic gases. For this, these values are true for monoatomic gases. Monoatomic is the gas whose molecule has only one atom. But for diatomic, triatomic, these values are less. I have explained. I am telling you the whole theory in one video on a glance, so that you can solve easily. Then we found that we got the concept of degree of freedom. For monoatomic gas, degree of freedom 3, for diatomic 5, triatomic or polyatomic 6 or 7. 6 at room temperature and 7 at very high temperature, because vibration of molecules will have also another form energy, and using that I derived. So using degree of freedom, internal energy per mole of gas. From this concept, kinetic energy per molecule, sorry, equal to, that came 3 by 2 kBT. K is Boltzmann constant. Since Boltzmann constant is universal constant, T is temperature. यानी kind per mole that is proportional to absolute temperature. Whatsoever be the molecule may be according to conserved gases. According to conserved gases, kinetic proportional to absolute temperature. So if you have gases like any gas, any particle, if they are at same temperature, then they have same kind energy. But fact was found wrong. Using degree of freedom, the energy was written as F by 2 RT. F by 2 RT, and therefore kind energy ये per mole है, per molecule, kind energy per molecule, correct, per molecule is equal to F by 2 kBRT, kBT, sorry. So, and also we determined कि भाई CV also we write F by 2R. F is the degree of freedom, and Cp equal to C plus R. So it will be F by 2R plus R. I mean, or it is equal to R into F by 2 plus 1. So we have to taking care of whether gas is monoatomic or diatomic or polyatomic while considering the value of Cp and Cv. There are many mistakes in books. I got it when I started solving the problem of competitive exam. Now in coming video I will be solving some simple question for you, and then I will take the question which have been asked in competitive exam. Dear friend, please don't go to that part that this syllabus has been deleted. Actually you have to learn the things. This is the age of learning. In coming future, when you become young enough, you have to perform so many duties, you will not get time to learn. If you work in the field of science, then you are more responsible person, and you have to tell the true facts to the people, and there is no limit of achievement. Who learn properly and take quality education, they get more and more, and people who do not learn properly, they get hardly any lucrative job. So please, if you like my video, please first of all like video. If you have not subscribed, subscribe my video first, and then share the videos to your friends. I am looking nowadays, viewers are very small for me, while the information which I am giving are not given to students easily. Thank you.